Hello students, I welcome you all on my YouTube channel. Continuing in this lecture series on differential equation, today we're gonna look at some rules for finding out integrating factor. In last video we saw what is an integrating factor and also we did some problems based on integrating factor. Now we will be looking at 5 rules for finding out integrating factor. These rules are basically proven results on integrating factor, and the proof of these results I'm not going to discuss here. All right, so let's start with rule number 1, or you can say result 1, right? So rule 1 is if the equation mdx plus ndy equal to 0 is homogeneous equation in xy and x and y, that is if m and n are homogeneous function of same degree, right? Are homogeneous function of same degree in x and y, then 1 by mx plus ny is an integrating factor of mdx plus ndy equal to 0, provided mx plus ny is not equal to 0. So see here, what are homogeneous equations, or what is homogeneous equation and what is homogeneous function? Okay, see, homogeneous function, if mx y is equal to x square plus y square plus 2xy, you would see degree of x square is 2, degree of y square is also equal to 2, and degree of this term is also equal to 2. Then we will be calling this function homogeneous function, right? Or if mx y is equal to x cube plus 3x square y plus 4x y square plus y cube, then also you will see degree of first term is 3, its degree is also 3, 2 of x, 1 of y, degree of third term is also 3, degree of x is 1 and degree of y is 2, so combinedly degree of this term is 3 and degree of fourth term is also 3, therefore degrees of all the terms are equal, hence we can say this function is homogeneous function. I mean to say, if degree of each and every terms are equal, then the function is known as homogeneous function, right? So what are homogeneous differential equation? If mdx plus ndy equal to 0 is known as homogeneous equation if this m and n, okay, if m and n are homogeneous function, right? If these two m and n are homogeneous function, then this equation is called homogeneous equation. Fine, homogeneous differential equation. And one more thing, these two functions should not only be homogeneous function, but homogeneous function of same degree. Okay, same degree. Okay, one more time I'm repeating this. Mdx plus ndy equal to 0 is known as homogeneous differential equation if m and n are both homogeneous function of same degree, then this equation is known as homogeneous equation, differential equation. Okay, for example, I'm giving you an example, right? X square plus y square dx plus 2xy dy, right? See here m is equal to x square plus y square and n is equal to 2x plus 2x into y. The degree of this is homogeneous equation, right? Degree of this and this term is same, that is 2. Okay, so therefore this function is homogeneous function, and also you see it is having only one degree, only one term, and degree of that term is 2, right? So therefore we can say this m and n are homogeneous function, and also these two function are having same degree, right? Therefore this equation is homogeneous differential equation. And what would be integrating factor in this case? Integrating factor would be 1 upon mx plus y, right? So here m is equal to x square plus y square multiplied by x plus 2x y into y, which is equal to 1 upon x cube plus x y square plus 2x y square, right? This is the integrating factor n for given differential equation, right? Now rule 2, or result 2, it says if the equation mdx plus and dy equal to 0 is of the form fxy y dx plus gxy x dy, okay, equal to 0, then 1 upon mx minus ny is an integrating factor, provided mx minus ny is not equal to 0. Okay. For example, xy minus 2 x square y square into y dx plus xy minus x square y square into x dy equal to 0, right? So see here, what is the key feature of this rule? In this case, one thing is function m must be in such way that x and y comes together, right? If x is in any term, then y should be also there, and not only there but in same degree, right? If x is present here in degree 1, then y should be also present here with degree 1. Similarly here, x is present in degree 2, y square should be also present in degree 2. That is, mxy should be equal to f of xy. That is, fxy should be together. For example, here if we take this function, let x is equal to x minus 2 x square, okay, then fxy must be equal to xy minus 2 xy whole square, which is equal to xy minus 2 x square y square, right? So this is the meaning of f of xy here, and once again I'm telling you that f xy should be all together, okay, and also y should be here in multiplication with y dx, right? uh, we said here mx minus ny must not be equal to 0, but what if mx minus ndy equal to 0? अगर ये 0 हो जाएगा, then how we are going to find out solution? Okay, how we are going to find out the solution in that case? Okay, let us try to look at it. Here mx minus I wrote it dy, it must be ny, okay, and here also I wrote it ndy, it is ny, okay. So if ny equal to 0, which means if rule fails, okay, then how we are going to find out solution? We are trying to look at this problem, right? Then mx minus ndy equal to 0 becomes mx is equal to ny, that is m is equal to ny over x, okay. Our differential equation was m dx plus and dy equal to 0, where m was equal to f of xy into y and n was equal to g of xy, x into y into x, right? Let me show you here. See, This was the equation, right? See, this is the term. This is the first term, which is equal to m y into y time fx y, and this is n g x y time x. Okay, and also you see mxy, m is equal to ny over x. So now replacing this m by this, okay, we get ny over x dx plus n dy equal to 0, right? So now this n could not be taking it common and taking it to the take it common and take it to the right hand side, we get y dx over x plus dy equal to 0. Okay, this and this has been taken common and taken to another side, which still becomes, or you can simply say, okay, this is not equal to 0, right? So whatever has been left inside, it must be equal to 0. So we are left with y dx over x plus dy equal to 0. Again, dividing throughout by y, we get dx over x plus dy over y equal to 0. Now integrating gives log x plus, okay, integrating, okay, let me explain fully. Integrating dx over x plus integration dy over y is equal to constant of integration. This is log x plus log y, fine, log y equal to constant of integration by logarithmic formulas. This is log, we know log m into n is equal to log of m plus log of n, okay, small n small m. Okay, this implies log of xy is equal to c. Now xy is equal to e raised to power c. Okay, this implies this can be written some another constant, xy is equal to some constant c, okay, capital C. Okay, I just want to tell you here that if you are having log on one side and another side you are having something c, then take exponential function on both the side. E raised to power log x would be equal to e power c. Exponential and log uh, are in inverse function of each other, therefore it yields x only, whatever is the with log x. Okay, so x is equal to ec. So this is what I did here. Okay, so thus in this case solution would be mod of x y equal to c. Also in earlier case, I would like to tell you here that in rule number 1, we also in rule number 1 integrating factor was 1 over mx plus ny provided mx plus ny is not equal to 0. Okay, if mx plus ndy is equal to my only. Okay, if this is equal to 0, why I'm writing and dy again and again, it is ny only. Okay, mx plus ny is equal to 0, right? So if it is equal to 0, then rule fails. Okay, failure. Now in this case, how to solve the given equation now? Because we are not able to find out integrating factor, because denominator has turned 0, so this is in not defined. So now we are going to look at the problem, how we will be finding out solution in this case, how to solve now. Okay, so now if here mx plus ny is equal to 0, again similarly mx would be equal to minus ny, and m would be definitely equal to minus ny over x. Therefore now original equation was mdx plus ndy equal to 0, so we can replace this equation, becomes minus ny over x into dx plus n, this is ny, okay, ny only, equal to 0, right? Now cancelling this n, we get minus y dx over x plus dy equal to 0. Again dividing throughout by y, we get minus dx over x plus dy over y equal to 0. Now see, integrating we get minus dx over x plus integration dy over y is equal to constant of integration. Now this is equal to log minus log x plus log y is equal to c, right? Again this implies we know log of m over n is equal to log of m minus log of n. Therefore this equation becomes y over x is equal to c. Okay, cancelling this log, we get y over x is equal to exponential c, which could be written some another constant c dash or capital C. Therefore y is equal to c, capital C, in time x. This is the solution of given differential equation mdx plus ndy equal to 0 when m 1 upon when mx plus ny is equal to 0. Okay, this equation is the solution of this differential equation when mx plus ndy is equal to 0. Otherwise we will be finding out integrating factor. If this is not equal to 0, then we can find out integrating factor mx plus ny, okay, and thus we would be able to solve the given equation. Now rule number 3. Rule number 3 says if differential equation, if in the differential equation mdx plus and dy equal to 0, curly m upon curly y minus curly n over curly x upon this second term n is function of x only, okay, say f of x, then exponential of integration of f dx is the integrating factor, right? And rule number 4 is also quite similar to rule number 3. It says e raised to power fy dy is the integrating factor of differential equation mdx plus ndy when curly m by curly y minus curly n by curly x upon m now, okay, m is equal to, or you can say is a function of y, say g of y, okay, or you can also say f of y here, but it would be good to separate these two function, okay. I'm writing gy here, okay, gy, this is gy, okay. If this term is equal to gy, then exponential integration gy dy, integration gy dy, this is integration of gy dy, right? Integration gy dy is the integrating factor of given differential equation, okay. Now lastly, rule number 5. It says if mdx plus and dy equal to 0 is in the form, is of the form x raised to power a y raised to power b my dx plus nx dy plus x raised to power a dash y raised to power b dash into m dash y dx plus n dash x dy equal to 0. If m dx plus n dy is in this form, then x power h y power k is an integrating factor where h and k are chosen in such a way so that a plus h plus 1 divided by m is equal to b plus k plus 1 divided by n, and a dash plus h plus 1 divided by m dash is equal to b dash plus k plus 1 divided by n dash. Okay, so these were the 5 rules for finding out integrating factor, right? This is it for today. Okay, and next class we will be discussing some problems on these rules, right? If you have any query or question, please feel free to ask me in the comment section. Thank you.